Yes, starting with the limit and then going to integral notation. Okay, the limit of a sigma notation, or summation notation, I should say. So, now learning how to read this. Okay, we're doing what you would call it, Riemann sums, right? And we're taking the number of rectangles to infinity, and so you have to remember that we're just multiplying the height times the base, and the height is found by multiplying the f of x sub I times delta x. Delta x is your base, and the f function with the x sub I plugged into it, that gives you the height. All right, so let's talk about our delta x first. Delta x is usually found by taking the upper bound, or the upper boundary and the lower boundary, and subtracting them. So I'm just going to write that by writing u minus L. This is the interval, okay? Interval. Let's just do int. And then on the bottom, you divide it by the number of subdivisions, or the number of rectangles. Now, in our case, it's infinity, so I'm going to use n, knowing that we're going to plug it into this cool limit guy right here, and take the number of subdivisions to infinity. Okay, so since that is usually our delta x, and over here we have our f of x with the stuff plugged into it, we know that delta x is like this. Now, that's kind of weird because there's a 2 on the bottom. I don't know if that freaked you out, but it freaked me out for a second. So what you're going to do here is we're going to get rid of that 2. To get rid of that 2, you're going to multiply the top and the bottom by 1/2, which is kind of weird because now we're interjecting a fraction inside of a fraction. So actually, I'm going to write pi on top, so it'll be pi over 2 on top, and on the bottom we'll have an n. And so there you have it. The interval is pi over 2. All right, that's good to know. Let's keep that, tuck that away in the back of our head. And then what's all this information in here going to give us? So think about it for a second. When we were finding x sub I, we would start with the lower bound. Oh man, I'm using a. I should have used the L, but oh well. We start with the lower bound a, and then we add to it delta x times I. Okay, so what is a? If you look at this, do you know what a is? Heck yeah, you know what a is, because you can clearly see the delta x times I right there. So our lower bound is definitely pi over 4. And so that limits what we are going to select for our answer, because only this one and this one start with the pi over 4. This is always the lower bound and this is always the upper bound, by the way, if you're a noob at integral notation. Okay, so which one of these is going to be the correct one? Are we going to go from pi over 4 to 4, or are we going to go from pi over 4 to pi? Ooh, pi over 4 to 3 pi over 4. I think I said pi, whatever. I don't think I said it right. Now, they both have the function sine x inside of it, which we kind of already knew. That was the function right there. That's f of x sine. So how do we know? Oh, that's what this guy comes in handy. We know the interval. So if we were to take pi over 4, which is our lower bound, and we were to add pi over 2, which is our interval, what would be our upper bound? Let's make this into a 4. That would be a 2. So this would be 3 pi over 4. Clearly, C is our answer.